Hello everyone, I hope you'll be doing all good. So in this video we are going to discuss about the electric circuits. This is topic 4.3 of GCSE O-level physics. So this topic is about the electric circuits. In the electric circuits, first of all we have to discuss about the electric circuits and its components. So that's the first topic, electrical components in an electric circuit. In an electric circuit, so we have quite a lot of components that we use in an electric circuits. I'm gonna name a few. For example, cells, and while drawing a circuit diagram we represent the cell by this symbol. Then comes the battery. We represent the battery with this symbol. For the cell, this is the positive side of the cell, that's the negative terminal. For battery, that's the positive, that's the negative. Then we have resistor. In order to represent it, this is the symbol for the resistor. And then comes, for example, bulb. This is the symbol for the electric bulb. Then switch with this symbol. This is the symbol when the switch is off. This will be the symbol when the switch is on. Okay. Now the next comes thermistor. I'll let you know what is it. So for the thermistor, we have a symbol which looks like this, and then we have LDR, light dependent resistor. For this one, this is the symbol for the light dependent resistor. And then we have some more electric components. For example, a voltmeter. It is used to measure the voltage. That's the symbol for the voltmeter. Then comes ammeter. This is the symbol for the ammeter. Then we have LED, light emitting diode. For LED, that's the symbol for LED. Okay. So these are some of the electrical components that are used in an electric circuit. An electric circuit is a combination of these components when they are used together. So this is some brief overview about the electrical circuits and its components. Now we have to discuss about the types of electric circuits. So the types of electric circuits. So mainly we have two types of electric circuits. Number one, series circuits, and number two are the parallel circuits. In the series circuits, the components are attached in series, like end to end. In parallel circuits, the components are attached in parallel orientation. We will discuss how the current and the potential difference behave in a series circuit and in the parallel circuit. And then we'll also see how the resistances of several resistors behave in a series circuit and in the parallel circuit. So let's discuss about the series circuit first of all. So series circuit. Let me just draw a circuit. For example, this is the cell, this is the ammeter, this is a resistor, this is another resistor, this is the positive terminal of the cell, that's the negative terminal of the cell. This resistor is R1, that resistor is R2. The direction of the current in this circuit, well, let me put a switch over here as well. So there's a switch, this is a switch. Okay, now when I turn this switch on, the circuit will turn on. So let's turn it on. When I turn the switch on, what will happen? The current will start to flow throughout this circuit. Okay, so we represent current with I, so I'll just write I. Okay, now we have to, let me just attach a voltmeter across these two resistors. This is V, another voltmeter across R2. So these voltmeters are basically measuring the potential difference of across R2 and R1. Now the cell, let's suppose the cell has a potential difference of 6 volts. Now what happens in a series circuit is, in a series circuit, the current through all the resistors remains same. So the current remains same through all the resistors. So whatever is the current that is passing through R1, same current will pass through R2. In this case, the current is I. So if current I is passing through R1, the same current I will also pass through R2. So in the series circuit, the current remains same throughout all the resistors. Now let's talk about the voltage or the potential difference. So voltage basically divides across the resistors in a series circuit. How? For example, the total voltage over here is 6 volts. So if 4 volt will be dropped across R1, then the remaining 2 volts will be dropped across R2. Or if 3 volts are being dropped across R1, the remaining 3 volts will be dropped across R2. If 1 volt is being dropped across R1, then the remaining 5 volts will be dropped across R2. So that's how the voltage divides in the series circuit. Now let's talk about the combination of the resistors, how the combined resistors will behave in a series circuit. So for example, I want to find out the total resistance of this series circuit due to these two resistors, R1 and R2. Okay, so resistance in a series circuit. So the total resistance in a series circuit, I'll represent with RT. It will be equal to R1 plus R2. So you'll just add up the two resistors and you'll get the total resistance in the series circuit. For example, R1 is let's suppose 20 ohm, R2 is let's suppose 50 ohm. Then the total resistance will become 20 plus 50, that will be equal to 70 ohm. So in this way you'll add up the resistances and you'll get the total resistance. Now let's talk about the current. The current remains same. Okay, we have already talked about it. We have to discuss about this ammeter. So this is the symbol for the ammeter. So ammeter is basically, it's an instrument that is used to measure the current through the electric circuit. So this ammeter will be attached in series in any circuit, and these are the voltmeters. These voltmeters are attached in parallel to any circuit. So this voltmeter right over here will measure the potential difference across R1, and this voltmeter over here will measure the potential difference across R2. So this is all about the series circuit, how the current behaves, how the voltage behaves, and how the total resistance of the series circuit. All right. Now after this we'll discuss about the behavior of current, voltage and resistors in a parallel circuit. Alright, so now let's discuss about the parallel circuits. So let me just draw a parallel circuit, and then we'll discuss how the current, the voltage and the resistance, how they behave in a parallel circuit. So that's the cell attached with the switch. Over here I have a resistor. There's another resistor. I'll call this as R1, this as R2, and this is the switch. Now let me just put an ammeter within these, between these resistors here and here. So I'll put an ammeter over here, an ammeter over here, and a voltmeter over here. That's the ammeter. There's another ammeter. That's the voltmeter. Okay, so this is the positive terminal of the battery, this cell of that's the negative terminal. Now when the switch is turned on, the current will flow from the positive terminal towards the circuit. So the current will come over here. At this point, some of the current will go through R1, and the remaining current will go through R2. But the sum of currents between R1 and R2 will be equal to the total current. Now how it behaves? So we can say the current divides in a parallel circuit opposite to the series circuit. So the current divides in a parallel circuit. Over here we have the total current. Let's name it as IT. Some of the current will go through R1. So from here we'll have I1, and the remaining current will go through R2. So it will be I2. Now the total current will be equal to I1 plus I2. Okay, that's how the current will behave in a parallel circuit. So the current divides in a parallel circuit. I'll write down this equation on this side. So IT is equal to I1 plus I2. Now let's talk about the voltage. So voltage remains same in a parallel circuit. So the voltage that you will see across R1 will be the same across R2. So this voltmeter over here will give us the total voltage. Now this voltage will be equal to R1 and R2. So the voltage drop across R1 will be equal to the R2, and it will be equal to the voltage or the EMF that is being provided by the cell. So let's suppose our cell is of 6 volts. It means that 6 volts will be dropped across R1 and 6 volts will be dropped across R2. It doesn't mean that the 6 will become 3 or half. No, the voltage in parallel in the battery, in the first resistor and the second resistor, it will all remain same. Okay, so this is how the voltage behaves in a parallel circuit. Now let's talk about how the resistances behave in a parallel circuit. So for the resistance, the total resistance, in order to find it out, we have to use this formula. 1 over R total is equal to 1 over R1 plus 1 over R2. That's how we find out the total resistance in a parallel circuit. Okay, so these are some of the characteristics of the parallel circuits that you have to remember. I repeat, current divides in the parallel circuit, or you can say the current splits in the parallel circuit. The voltage or the potential difference, it remains same in the parallel circuit, and by using this formula you can find out the total resistance in a parallel circuit. Okay, now after this we have to I'm gonna solve an example of how we can use the concept of series circuit and the parallel circuit to find out the current or the voltage in a circuit. Okay, so let's suppose we have been given this circuit. Now in this circuit we have a battery, two resistors and we have been given the values of the two resistors. So for example, R1 is 15 ohm, resistor 2 is 10 ohm. This is the battery whose voltage is unknown, but we have been given the voltage across R2. The voltage across R2 is 5 volts. Okay, now we are supposed to find out the total current in the circuit, the voltage across R1 and the voltage across the battery. So let's start off the working. So first of all, we'll use the concept that in a series circuit, this is a series circuit, so we'll use the concept that current remains same in a series circuit. The current remains same in the series circuit. So the amount of current that will pass through this resistor will be equal to the amount of current that will pass through this resistor. So if you are able to find out the current across R1, then we'll use the Ohm's law to find out V1. Once we find out the V1, then we'll just add up V1 and V2 to find out the total voltage. Okay, so for the first step, let's use the Ohm's law, that is V equals to IR to find out the current across this resistor, current through this resistor. So voltage is 5, I is unknown, and times it by 10. I'll divide both sides by 10. So my I will become equal to 5 over 10, that will be equal to 0.5 amperes. So 0.5 ampere is the current that is being passing through R2. Now since in series circuit the current through the resistors is same, so the total current will also be 0.5. So for the total current, I'll write it as I is equal to 0.5 ampere. Now it's this turn, we have to find out V1. So let's again use the Ohm's law, that is V equals to IR. Now I know that the current through R1 is 0.5, so I'll put 0.5 here, times it by the resistance, that is 15, so I'll write 15 here. Now 0.5 times 15, that will be equal to 7.5 volts. So the voltage drop across R1 is 7.5 volts. So now we have the voltage drop across R1 and R2, so we can find out the final volt, like the total voltage of the battery. So the total voltage of the battery is V, that is equal to V1 plus V2. So V1 is 7.5 and V2 is 5. So when you'll add them, the final answer will become 12.5 volts. So the total voltage of the battery is 12.5 volts. So this is how we'll use the concept. We have just used the concept of the current remains same in a series circuit to find out the total current, the voltage across R1, and the total voltage across the battery, right? So that's just an example of how you can use the concept for the parallel circuit or the series circuit to work out your required current, potential difference, or the resistors. So there are two important factors that you have to keep in mind. One, the rules. The second thing, the Ohm's law, V equals to IR. That will be applicable everywhere. So this is it for the example for the series circuit and the parallel circuit. Okay, now we have to discuss about the action and use of some of the circuit components. So let's discuss some of the circuit components. In the beginning, I have discussed about the symbols. Now we'll discuss some of the functionalities of the circuit components. Alright, so now we have to discuss about the action and use of the circuit components. Action and use of circuit components. So we have already discussed about the ammeter, voltmeter, resistor, battery, switch. Now we have to discuss two more components. Number one is thermistor, and the other one is the light dependent resistor. Light dependent resistor. So for thermistor basically it's a heat sensing resistor. Okay, we can say it's a heat dependent resistor. So for a heat dependent resistor, what happens is when the amount of heat across the resistor increases, its temperature, its resistance decreases. First of all, let's discuss the symbol. Let's see its symbol. So this is the symbol for the thermistor. So as the temperature across this resistor increases, the resistance of the thermistor decreases. As the temperature across the resistor increases, its resistance will decrease. We call it a negative thermal coefficient resistor. Why negative thermal coefficient? Because heat is, when the heat increases, the resistance drops. There's also another one that's called the positive thermal coefficient resistor. So for that one, if the heat increases, the resistance will also increase. But for a negative thermal coefficient resistor, as the heat increases, its resistance will decrease. So for now, you can just remember, as the heat across this type of resistor increases, its resistance will decrease. Okay, now the other one, it's the light dependent resistor. So the symbol of such a resistor is like this. LDR, light dependent resistor. It's basically a light sensing or light controlled resistor. So as the intensity of light across or around LDR, we call it LDR like as a short term, increases, its resistance will decrease. So this is basically light dependent resistor. As the intensity of the light around the LDR increases, its resistance will decrease. So these are some of the actions of these two type of resistors, thermistors and LDR. So basically these type of resistors, they are used as the sensing devices. For example, thermistor can be used as a sensing device in a heat controlled devices, in temperature controlled devices, and LDR can be used in such devices that are controlled by the light. For example, it can be used as a switch for light that turns on at night and turns off in the daytime. So these are some of the action and use of these two electric components. Now the next thing that we have to discuss is about the potential divider. Potential divider. Potential divider circuit. So the main role of this potential divider circuit is to divide the potential into two values basically. So it looks like this. That's the cell. That's the first resistor. That's the second resistor. And these two are the outputs, and we'll put this as a variable resistor. Now this is another type of resistor, we call it the variable resistor. Variable resistor is such a resistor whose value can be changed, whose value is not fixed. Okay, so that's the variable resistor. Now that's negative, that's positive. The current flows through the circuit like that. Okay, for example, the total voltage is 12 volt of the cell. If 6 volts are dropped across the variable resistor, then the remaining 6 volts will be dropped across the other resistor. Why? Because as we have just discussed in the series circuit, that the voltage across the resistors add up to the total voltage across the resistor add up to the total voltage. So 6 plus 6 will be equal to 12. Now what if we want, this is the output voltage, we can apply any appliance over here across these two terminals. This is our appliance. Now this appliance works on a voltage of 9 volts. Okay, so we want more voltage over here. In that case, in order to get more voltage over here, what we do is we will reduce the voltage across this variable resistor. In order to reduce the voltage across this variable resistor, we have to decrease its resistance. We have to decrease its resistance. Why? Because according to the Ohm's law, V is equal to IR, or we can say V is directly proportional to R. If we have more resistance, the voltage drop will be more. If we have less resistance, the voltage drop will be less. So we want less voltage over here. We want 3 volts over here and 9 volts over here. Before it was 6 volts, 6. Now in order to get 3 volts over here, we have to decrease the resistance of this variable resistor so that the voltage across this variable resistor become 3 volts and the remaining voltage will be across the other resistor. So in this way we'll attach the appliance, and this appliance will be receiving 9 volts. Okay, so that's how it works. In order to check the voltages, you can attach a voltmeter over here. This will show you the total voltage of 12 volts. Then you can attach a voltmeter over here. This will show you 3 volts, and then you can subtract 3 volts from the 12 volts and you'll get the remaining voltage over here. That's 9 volts. So this is the role of the potential divider. I'll write it here. The potential divider circuit. It is used to divide the potential difference by using a combination of two or more resistors. In most cases, there are two resistors. Alright, so that's how the potential divider circuit splits or divides the voltage according to our required conditions. So this is it for this topic. I hope you got it. If you have any question, you can just leave your comment and I'll try to answer it as soon as possible. Thanks a lot.